Let's now understand what challenges you can face while inserting new rows. Turns out you can violate constraints like not null or unique. So when this happens, the default is basically to crap out of the insertion. That is, no rows will be inserted. So that's what this corresponds to, the abort strategy. In SQLite world, there are a bunch more knobs that you can tune to your liking. So here are a few. Say a unique constraint is violated, then specifying the conflict resolution strategy as replace deletes the existing row and inserts the new row. Fail indicates that if you are inserting a bunch of rows like here, like in this scenario, you can specify fail so that changes will be stopped where the first failure occurs, and then nothing else will proceed beyond that point. So rows till the time failure occurs will be inserted and the rest of the rows will be ignored. Rollback and abort are similar, except that rollback comes into play in transaction scenarios. We will look at this when we dig into the transaction section of our lessons. And finally, ignore. For all you data scientists out there, please keep an eye on this. It's important because say you are importing a brand new data set into your database, odds are good that you would want to use this conflict resolution strategy so that you first get a feel of how good or how clean your data set is. For the rest of you, clean means that the data follows a certain format. So we have seen that each data has, or each column has a data type. Missing values and incorrectly specified values would make the data set is what is called as dirty. So ignore skips the one row that contains or the constraint violation and continues to process the rest of the rows. This way, when you have IDs associated with rows, you can pinpoint exactly which rows are unclean. Let's now see a bunch of examples on how to use these conflict resolution strategies during insert. Let's now look at a bunch of examples for conflict resolution. We first create a table called T1 with two columns K and V. K is an integer and V is a varchar. For those of you who are familiar with hash table data structure, K would stand for key and V would stand for value. K has a unique constraint. Let's see what happens after the first insert. We're going to perform an insert of two columns K and V with values 1 and 2, and the corresponding values are will insert 1 and will insert 2. So both these inserts will actually succeed at this point because the table didn't exist for starters. It was just created, it's blank, so there won't be any conflicts as far as this unique constraint is concerned. The keys are distinct, so both of them will go through, and so both these rows will get inserted. Let's look at the next statement here. Replace into T1, which means that either insert if the key is not present, or if there is any conflict resolution, then replace the row. That is, delete the old row and insert the new row. So here we are inserting two rows again, 3 and 1 with the corresponding values. What will happen here is 3 was never in the table to start with. We had only two rows with keys 1 and 2, so 3 will get inserted, hence the value as well insert 3 for more clarity. Whereas in this one, this particular row will now replace this previously existing row. So the new key and value will actually be 1 and will replace 1. Similarly, if we look at this ignore as a strategy, when we use that for conflict resolution, let's see what will happen here. So here we have two rows that are being inserted. The closing bracket here is hidden in the presentation, but I'm sure you can understand that it's going to be something like this, a closing bracket and then a comma. So again, we're going to have two rows getting inserted, one with K3 and another one with K value equals 4. Since we use ignore as a conflict resolution strategy, since 4 was never present in the table for starters, 4 will get inserted. Whereas if you see 3 has already been added here as part of this statement and it's already in the table. So this row will never get updated, or basically this insert will be ignored. So the end of the statements, once we issue a select and order by k, the keys will be ordered in ascending order since we have an order by k phrase at the end of the statement. And here you'll have the corresponding values associated with the keys. So 1 was replaced because of this particular statement. 2 was inserted into this table from this statement and it was not touched ever since. 3 was inserted here but was not replaced because we used ignore as a conflict resolution strategy. And finally 4 was inserted as part of this particular statement. If you look at all these cases, a row was either inserted or it was ignored or replaced. There was no partial operation that was allowed down an existing row. For example, if you wanted to have some sort of a counter, there was no way for you to do this. Using just these constructs, a way to maintain a counter, say if you wanted to maintain a word count, so number of times a word occurred in a certain text, then we would retrieve a row, update the counter. If the row didn't exist, then we would consider the initial count as 0, and then finally you can use replace into. So that's how you would perform a word count operation. Turns out there is actually a nice way to do this in the SQLite tree world. So this one either updates or performs an insert. Let's see this with the example. So here we have the word count table. Again, the reason for picking this is those of you who are coming from a big data world, word count is pretty much like the hello world program. You have a certain text or you have a lot of documents. You want to produce a count of the word and the number of times the word occurred in all the text together. So here we have a table called word count. Word, and the primary key is a text type, and the next one here is a count, and the default is 1. Let's see what happens when we execute the statement. So here we have insert into word count, and we're going to insert 3 rows, apple, banana and apple, with a slight modification on conflict of word. That is, if this word already existed and led to a primary key violation, then do update, set count equals count plus 1. So when we insert the very first row apple, this part wouldn't fire. However, this part would get activated. So apple would have a count of 1. The same would happen when we insert banana. However, when we insert the third row apple, there would be a conflict as far as the column word is concerned. So this part would fire off. The count would be set to the existing count 1 because the default is 1, and then you'll add 1 more, and so the count will become 2. So when we run a select statement, here we'll have word and count, apple will have a count of 2 and banana will have a count of 1. So this is yet another conflict resolution strategy where you have the flexibility to update an existing row.